So let's now step a bit about the job rules in this domain. Now here I'll like listed down a lot of job rules, but not all of them like related to the optimization. For example, like if we want to take, let's say, about the optimization, RF engineer, like MPO engineer for planning optimization engineer, design engineer, optimization engineer, network design optimization engineer. These are, let's say, the job titles that you mainly see for RF. Let's say if you have many years of experience in the RF domain, you can work as solution engineer as well. You can who would like to work as a solution will be like working with the pre-sales team. Other than that as well, you can work as a high-tech engineer where like you'll be like an interaction with the product line, and you'll be like testing all the new features. But telecom domain or cellular domain, it's really, really wide and vast one. It's very big one. So you have a lot of opportunities. So what we talked about is only, let's say, the opportunities in the 4G domain. But let's say you wanna take care of the system, for example, you can work as a RAN support engineer, NOC support engineer, or system engineer. So all of these ones, like you're working directly in the system. It's not related to the RF domain, but as well as it's there actually. So like a lot of opportunities for, let's say, system engineers. You have the core as well, like you need core support engineer, and under NOC support engineer will be like working on, let's say, core, let's say transmission. You can like, or transport engineer, you can work as well on routing or switching, let's say router switches, because they are as well there in the network. You'll be working as well on the RAN equipment. And let's say that you work, let's say with the network rollout, you will be working mainly as integration engineer. And under the optimization or RF domain, you'll find something called, let's say, the planning here, MPO, or design. This mainly under project, let's say rollout or project implementation, as well as from the optimization, you might find something called like pre-optimization or initial tuning optimization, where there's like need to start tuning the network when it's still, let's say, new. Other than that, you'll have, let's say, for sure, research domain. Research domain is quite huge. You will have, let's say, R&I department, research and incubation team. Mainly, like I worked with them, it's like you are mainly responsible to do research in the standard. So it's mostly like will be simulations on MATLAB, C and C++, like in order like to test like new algorithms and how you can improve the existing one, how you can build something new. Then you have, let's say, the R&D, research and development will be like, it's close to the R&I, but the R&I mainly they are working on the standard. By the development team, they're working like as software developer, hardware developer, let's say, baseband developer engineers, as well as you have like upper layer developer engineers, like for Mac layer, for the BDCP, for like layer 2, which is Mac, BDCP. You have SDAP as well introduced, let's say, on the 5G. Other than that, you will have as well the OS engineers, as we've seen like before. We had like a figure for the KPIs, which was taken from the OSS. So for the OSS as well, you have, let's say, OSS support engineers. You have OSS development engineers. So as well, OSS need like complete teams here. As well as for the, like we talk about security, for sure you need like security engineers as well. So still like you have field engineers, you have the management staff, you have logistics. So a lot of opportunities are there, let's say, on the cellular domain. But when we talk about optimization, we mainly mean these things: RF, MPO, design, optimization, NDO, solution, or high-tech engineers. So it will be mainly like about like these, let's say, titles. Now I will just like introduce like two small case studies, which common nowadays in our let's say networks. Low throughput, either in downlink or uplink. So this is like very common issue nowadays, that at some times you like have 40 big throughput, others you'll have 20, others you'll have 5. Then sometimes you go toward the, let's say, 3G network. A lot of people are, like to say, complaining about these services, and you receive a lot of complaints from the customer that you are not getting the service, etc. And believe me, guys, like, and girls, everyone, like, it's not easy actually to provide good throughput all the time. And it needs a lot of investigations. Let's say, for example, I have a low throughput issue. So first thing, I have to analyze the radio conditions. like RSRP levels, SINR levels in that area. I have to check signaling flows. I have to do, let's say, logging messages. I have to check the cell loading issues. So it's not easy actually. If you, let's say that if you just want to list the factors that might affect, like, you'll never finish. For example, it might be high blur, high, let's say, block error rate. It's causing, like, and the block error rate, it might be like due to bad coverage, that you are like in a poor coverage area. Maybe you are a deep indoor user, like the 4G is not good, let's say, still for the indoor users. Maybe you'll have some interference, that you'll have like more than one base station covering you, like with a good signal in this area, so you'll suffer from something called CQI, so you'll have bad CQI. So this will as well like introduce interference, which will affect your throughput. And sometimes you will have, let's say, some wrong parameter setting in the network side, that you need like to go and check, let's say, some features, if they are enabled properly, which parameters you need to change, things like that. Sometimes you'll be suffering from scheduling algorithms, like it will be, for example, like different algorithms. Maybe, let's say, it's not working properly, so as well as you need to check that. Let's say maybe you'll have hardware issue. Let's say VSWR, let's say we always say it like this one, will figure it out. If you work in this domain, you'll know what's the VSWR and how we are testing it, like using SiteMaster. So it might be hardware issue. You might be suffering from, say, backhaul capacity or transport network. So that means like you are not, let's say, receiving, let's say, good, how can I say it, good capacity from the backhaul. The backhaul is discongested. So you need like to upgrade the backhaul, and this one like will take a lot of time. For example, one time we suffered from an issue due to backhaul network, and it took the operator almost 1 year to upgrade the backhaul. And after they upgrade this backhaul network or the transport network, actually our issue in that area resolved for the throughput issue. So as I said, like to troubleshoot either downlink or uplink throughput, it's really tough. You need to check OSS KPIs. You need, let's say, to send the drive tester to the field or walk test in the field to check the RF conditions. You need to see your power settings. You need to see the user, what are they are getting exactly. Are they are getting, let's say, high modulation orders like 64 QAM, 56 or something like that. How many antennas are serving them? All of this you can see it actually from the, let's say, drive test logs, and sometimes from some OSS KPIs. You need to check the counters. You need even like sometimes to check the numbers of users in the cell. Maybe like you have a lot of users under one sector or one cell, and for sure like you can't provide all users with good throughput. So this is as well a bottleneck. So you need like to do some actions, like in how you can, let's say, release some users, how you can like make handover easier toward other, let's say, base stations or other, let's say, eNodeBs. As well as you need to check, as well as we said, like the transport network. Sometimes as well you need to check the license, because usually when some features need some license to be installed in the network and enabled, like sometimes maybe some mistake that the PDS is not taking the license properly, so this one as well need to be checked. As well as like let's say the bandwidth that you have as well might be an issue. Sometimes you'll have let's say TCP, wrong TCP setting in the, let's say, the eNodeB side or something like that. And one time as well we had one issue due to UE. For example, we had an issue like back on the day of iPhone, I guess 6 or 6 Plus, when they did one software upgrade. We had suddenly like higher drops, and we figured out that it was due to this software upgrade. Something like wrong happened, it seems, with the software. So after that, it was fixed with, let's say, a software upgrade from Apple actually. So they realized that there was like a problem when they roll out their software upgrade. So after that, there will be like a correction update. So this is one common issue that everyone's suffering from nowadays, like low throughput on our network, either for downlink or uplink. When we say downlink, it means from the eNodeB toward the UE device. When we say uplink, it means from a UE or smartphone or mobile, let's say, or iPad toward the base station or toward the eNodeB. Other problem, which is like mobility. Mobility, it means like when you are moving, let's say that you suddenly, let's say, lose the coverage or the data throughput will become very bad. And this is actually very common, and it's really, really earlier it was really harder than nowadays, because nowadays we have some new features which are introduced on the network, like on 4G, something called ANR, where the network can optimize, let's say, the parameters by itself. But it's not like you can't find it worldwide. So, for example, like in some networks, not some, in many networks nowadays, like you don't have ANR. Like out of the networks I worked on, maybe like 4 or 5 networks already, only one we had ANR enabled, and it's still not yet, let's say, mature. It was LTE Star network in Japan, and it was not that mature. It's still like sometimes it's doing. You feel that it's some mistakes can happen actually, like some like handover neighbors are not properly, let's say, added or deleted, something like that. So this mobility issue is really a big issue nowadays. Like because let's say now 5G is coming, so you need like as a 4G optimization, you need to keep like the connection on the 4G devices, and you need to know how you can, let's say, hand over toward 5G, toward 3G, and toward 2G. So this will really make it really, really complicated actually. So mobility issues, you will have a lot of problems there as well. If you have a fast moving UE, let's say you are driving a car on a highway or you are in a train, you will usually suffer from this mobility issues. Let's say, for example, if you are in a train, usually like there are some solutions like in the train stations called like the IBS solutions, and in the train there is something called GSM railway solutions. But as well as, let's say that the service provider you are with doesn't have like such services yet, you'll be suffering, let's say, from drops all of a sudden. Maybe you'll be like talking in a call and you'll feel that there is, let's say, a silent moment or something like that. So this silent moment, it means that you'll be like, maybe you're in a handover session, maybe like you're on a very poor RF connection, you need like to hand over, but because you are moving in a high speed train or high speed UE, so this handover like or solution is really hard. I don't want to spend like too much time here, but I just mentioned these like 2 case studies because they are really common, especially the throughput one. Actually, throughput like worldwide nowadays, it's quite tough actually to maintain. Lastly, I'll just talk about the research trends. As we can see here, like this one, I took it from the IEEE Communication Magazine, 2019. Let's say that here nowadays we are like 2019 and 2020, we have, let's say, the 5G product, which is already like tried done and deployment is done actually. So now we are working here, like if you see, like you have release 10, release 11, 12, 13, these are like we call the 3GPP releases. 5G started from, let's say, release 15, 16, and 17. It was like only introducing release 15. It's like was not much here. Like we mainly consider about the new features about IoT as well. It was introduced in release 14 and 15. Now, if you go and let's say, like to say 5G is now a reality. So the research now is mainly concentrate about, let's say, the 6G. So let's say that what would be like 6G like? So some of people said like we have Internet of Things, IoT. We will like targeting something called Internet of Everything, IoE. How we can, let's say, improve? Shall we go, let's say, to provide more capacity and more throughput to users? Shall we go higher? Let's say now we are working in the millimeter wave band. Shall we go up to, let's say, sub terahertz band or terahertz band? So this is like as well an active research, like to go for frequencies more than 60 gigahertz. But for sure, we have to keep in mind, let's say, the health effect. For example, out of let's say people saying that with the higher frequencies, like the 5G, start affecting the health, blah blah blah, stuff like that. You can hear it, but it's not true. Actually, there are like studies which is done, and it shows that still even like the 5G higher band, it's not ionizing, let's say, the human body cells, so it's not merely affecting actually. Actually, it's like, it's even blocked by the human body much more than the 4G signals or 3G signals. Another thing, let's say for the 6G, they are talking about like, let's say automated driving. Will be like sitting in the car driving by itself. Now already in 5G, we have V2X and we have V2V, like this is like standard for vehicle-to-vehicle communication, vehicle-to-everything communication. Let's say, so in 6G, they are thinking about automated driving. Let's say nowadays, if you remember, I introduced before like some cellular structure where you have like different base stations and different TEs. Now they are thinking to build, like already even the research already started. If you like, you can check in Sweden. They already started something called distributed massive MIMO or cell-free massive MIMO. So cell-free massive MIMO, that the whole network architecture will be different. It will be not like cellular like base station. It will be like antennas, let's say, spread it everywhere and provide good services. Other thing, let's say machine learning nowadays, actually, it's an active research area for like 6G, like machine learning, AI. It will be like playing a big role, as well as we can't, let's say, forget about smart surfaces. There as well, like, let's see, a lot of research is done for smart surfaces or smart metallic surfaces, how like the surfaces even like that will be like more smarter in order like not to say to act like an obstacle for the signal. So this is like as well an active research area. Beside that, you'll have, let's say, edge computing, security as well, maybe, let's say, holographic videos, energy efficient communication. All of these are like an active research area nowadays. And believe me, research is not easy. It's becoming harder actually every day. So now let's say what you need, like for example, for this job role or something like that. What actually you need, like you need to, like for this course of work, you need, like for example, to have fundamentals of cellular communication or cellular technology in order to be able to build up by yourself, like you say, your knowledge on this, let's say, domain. Some people say why, like as I said, like we're talking about 4G optimization. As I said, it will be around for the next 10 to 15 years, even maybe more, we don't know. For example, till nowadays, we have some engineers who are like even like maintaining the 2G network, and 2G was introduced back in 1992, and you're already in like 2020, so it's like 28 years. But you still have some engineers like working to maintain the 2G network, but for sure they're not working only in 2G, they're working on 2G, let's say, with 3G at the same time. And 3G, it was, let's say, globally from 2006, 2005, it was common everywhere. You still have like the 3G engineers, it's like more than 15 years now, and they are still working because they're like acting as a backup for the 4G network. So still, let's say you have like many years, like on this line of work, this course of work, like the 4G optimization that will be working there actually to, like, first to provide the main layer for the data. After that, let's say to act as a backup for the 5G network after they become mature. Let's say, for example, if you work in such domain, what will you gain actually? Now, like in academia at university or something, you study, let's say, deep in the system, the math equation, stuff like that. If you work as a 4G optimization or like say 5G optimization in the future, you will have like the chance to like look at the big picture of the cellular network. How actually, say, the mobile network works in real. For example, let's say that you work in research, you'll be working in a certain thing. Let's say you are working on baseband developer, you are working as a passband developer, you're working on transceiver design, you are working on like FPGA developer. So for sure, we're like, you'll be like only concentrate on this small thing. But if you work as a 4G optimization, 5G optimization, or 3G optimization, you'll get the chance to see like how actually the mobile network works in real. What's actually happening, let's say, on the street, like what's happening like beyond the research, what's happening, let's say, with the actual traffic, because whatever you do in the research, you will never be able to approach what's happening in reality with the users and the traffic. Whatever you do, it's like you can't just approach it. How to get into this domain? Initially, you must be, for example, like mostly holder of like electrical engineering, electronics engineering degree, morely toward, let's say, telecommunication. And there's one thing that I have to mention, like here, like you must always have the interest to challenge yourself, because this domain compared, like the technology domain compared to other domains, it's really evolving quite fast. So you need to keep up with the technology. So you need to read a lot. You must have an interest. So I always say like interest is really, let's say, very important thing, because if you don't have this like too much interest, you'll be like really like suffering like in order like to keep up with the new technology. You must be as well like self-learner. You must like be able to learn by yourself. You don't need like, for example, like to always, let's say, wait for the company to give you training or something like that. They always like you have to be like active and do like things by yourself, like looking for new technologies, stuff like that. So simply like you need to wake up every day and have an idea in your mind that you need to be better than the previous day. Like I'm looking, for example, like to learn something new, as well as you need to love what you are doing. You need like to be in love with the technology, because it's not like salary at the end of the month. Actually, if it's like you're taking it as a job, it's only like as a salary, and I don't think that you'll be like enjoying it. You'll be actually having very bad time on like at work, because you'll not like it actually. As well as you need, let's say, to keep, let's say, work-life balance, and I will add to it study work-life balance, because you'll be always like reading something new. So for sure you need like to have, let's say, good balance in order, let's say, to recharge your batteries, in order to like to be able to read more and to learn more. And always give time to, let's say, family, friends, go out to cafes, something like that. So this is how you can get into like such domain. Be like fan of technology. So that's all for today.